Today's lesson is on tricky exponents and graphing exponential functions. So, tricky exponential word problems. It says the value of an antique car is modeled by the function that, where x is the number of years since 2005, by what approximate percent rate is the value of the car increasing per year? So I want to know the rate. Well, normally this is where, remember, and this is the starting value, and this is what it's increasing or decreasing by. So normally we look right here. What's tricky about this is that they have put a number, and in this case it's a fraction, in the power. What that does is that affects this value. So I can't just look here. So what I have to do is I have to actually do 1.009 to the 2/3, figure out what that is, and then decide what my car is increasing by. So I take my handy dandy calculator and I very carefully type in 1.009 to the 2/3. Hit enter. So I have 1.00599. So let's write that down. 1.00599. So I can tell that this is increasing because we are above 1. The question is, how much above 1 are we? Well, you can do this in your head or you can do this on your calculator, whatever makes the best sense to you. So I'm going to take 1 and I'm going to subtract, I'm going to take my 1.00599 and subtract 1 out of it. So that's how much I'm growing by. Okay, so now scoot your decimal 2 places. So if I have 0.00599 and I scoot my decimal 2 places, then I'm growing 0.599%. Okay, so which one says that? Well, none of them say that, but which one rounds to that? And that would be 0.6, because 0.599, the 9s would round the 5 up to a 6. So I'm growing by 0.6%. Okay, let's try another one just like it. The value of an antique toy car is modeled by the function that, where t is the number of years since 1965, approximately what percent rate is the value of the radio increasing each year? So look here, normally that's the only place I have to look, but you can tell that they have a fraction in the power, so I have to deal with that. So I take my handy dandy calculator and I type in 1.008 to the 1/2. And I have 1.00399. 1.00399. So I need to see how much above 100% that is. Well, if I subtract the 1 out, that's going to give me 0.00399. But now I need to turn it into a percent, so I scoot my decimal 2 places, and that lands me here. So 0.399%. So that's probably going to round to 0.4% right there. The value of a house in your neighborhood can be modeled by that function where x is the number of years since 1995. By what approximate percent rate is the value of the car decreasing? Okay, so we're decreasing now. And I can tell that because my number's less than 1. But because I have that fraction in the power, this is them trying to be sneaky, I have to type it in. So 0.92 to the 1/3. Hit enter. I have 0.9726 if we round. 0.9726. So what I need to do is I need to figure out how much below 100% that is. Well, 0.97 is about 97%. That is 3% below 100%. The value of a diamond ring that's been in your family for generations can be modeled by that function where X is the number of years since 1960, by what approximate percent rate is the value of the ring increasing in value? I know I'm increasing because I'm going bigger than 1, so I take my handy dandy calculator, 1.002 to the 4/5. 1.001599. 1.001599. Subtract the 1 out of it because I'm trying to figure out how much above 100% I am. Scoop my decimal twice. So 0.159. So we're going 0.16. Okay, so now let's graph. Graphs of exponential functions are super easy. Well, the extent at which we're going to look at them is super easy, but there's one tricky part. This is my y-intercept. It is my starting value, if you'll remember from yesterday. Just like when you have y equals mx plus b, this is my starting value. This is my y-intercept. This is my starting value. This, if it's bigger than 1, we're growth. If it's smaller than 1, it's decay. And we've dealt with that the past couple of days. If it's bigger than 1, then I'm appreciating. It is increasing in value. If it's smaller than 1, it is depreciating. It is going down in value. Okay, so people look at number 1 and they say, oh, okay. And the number 1 mistake is they say their y-intercept is a 5. But that 5 is the guy being raised to the power. That's B. What's A? If you don't have a number up there, then your A is 1. So this graph starts at 1 on the y-axis. His y-intercept is a 1. Now this 5, which is my B, tells me if I'm growth or decay. Well, 5 is bigger than 1, so we're growth. So here's what it looks like. If this is my y-intercept, then I have this imaginary dotted line that is 1 below it. And that's called an asymptote. And what that means is I can't ever cross that asymptote. Now this is growth, and here's what growth does. Growth starts out really slow, but then the growth really shoots up and gets big. So the growth starts out really slow, and then it hits that y-intercept, and then it just really shoots up. Okay, so let's look at this next one. My starting point is a 1 because my A is a 1. I am decay because my B is a 1/3, and that's smaller than 1. So my y-intercept is a 1. The asymptote is 1 below it. Decay starts tall, and then it just really drops out, hits that point, and then levels off. Okay, so here we go. We're talking about where's the y-intercept and is it growth or decay? So this one is going to start at 3, which means the asymptote is going to be 1 below that. And 2 is bigger than 1, so it's growth. So it starts low, hits the point, and shoots up. This one starts at 2. 1/4 is smaller than 1. So this is decay. So it starts tall and goes down. Number 3 starts at 5. Asymptote is 1 below it. 3 is bigger than 1, so we are growth. Number 4 starts at 4. Asymptote is 1 below it. 2/3 is smaller than 1, so that's decay. Okay, so now what have we done? Now we are adding and subtracting numbers on the end of our function. And all that does is it takes our function and shifts it up or down. Okay? So we start at 3. We are growth. But then we get shifted down 4. So I start at 3, but then I get shifted down 4. 1, 2, 3, 4. Asymptote is 1 below it, and I'm growth. So this point ends up meaning nothing. But it was where I started. I start at 3, and then from there I go down 4. Okay, so let's look at number 6. I'm going to start at 2, because that's him. This tells me I'm decay. And that tells me I'm going up 3, because it's positive. So I'm going to start at 2, and then I'm going to go up 3. Asymptote is 1 below it. Decay starts tall and levels out. Number 7 starts at 5, growth, and down 8. So 1, 2, 3, 4, 5, down 8. So 1, 2, 3, 4, 5, 6, 7, 8. Asymptote is 1 below it. And growth. Growth starts low, gets big. Okay, this one starts at 4, decay because that's smaller than 1, and down 4. So starts at 4, down 4, asymptote is 1 below it, and decay. Decay starts big and gets low. Okay, the function is replaced with f of x plus k, resulting in this graph. What is the value of k? Well, let's talk about this guy first. Where would he be? Well, he would start at 3. Asymptote would be 1 below it. And the 1/2 would be decay. So that's him. What has happened to my graph? Well, it's still decay, but it has been shifted. So let's see how much it's been shifted. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's been shifted down 9. So what would you have to do here to shift it down 9? You would have to subtract 9. So find out where he is, find out where he ended up, and then decide what you need to do to him to shift him in that direction. Okay, same thing. So we have this function. Let's see, the original one started at 3. 1, 2, 3. Growth, not a problem. Replaced with this, so what's the shift? Well, it went down 1. So we need to shift it down 1. Okay, now this one just wants to know what's our function. So let's check these suckers out. Let's look at A. That'd be growth. Yeah, I like that. It would have started at 1 and then have gone down 3. No. This one would have started at 1. Growth, because of the 4, bigger than 1, and gone down 3. 1, 2, 3. No. This one would have started at 1, because that's my number in the front. Growth, because of the 3, and gone down 4. 1, 2, 3, 4. Yep. Number 12 just says, what's the y-intercept? Well, where would you have started? You would have started at a 2, and then we go up 5. So if I start at 2, and then I go up 5 more, where am I? I'm at a 7.